what that means is that I work on research mostly, and my day-to-day life comprises of reading papers, talking to students, reading a lot of other people's papers, keeping abreast of all the research in my area that's been going on. So my area is quantum computing and quantum information. So that is a next generation of computers, we like to think, that has like improved capabilities, and also added functionalities that may not be possible with the computers we have today. It basically is a way to fundamentally in the sense that using very fundamental physical laws at very microscopic levels, quantum mechanics, to redesign computers and the way we think about information. So if it works, it will revolutionize computing. But there are challenges. Energizing. I like conferences. Well, they basically I see part of our work as scientists is to disseminate information and to gather information about cutting edge research, right? Like what people are doing, and basically everyone's connected. Like in my area, at least, I think that's true in a lot of the other areas I see as well. That you share information, you collect information, and then you contribute in your way, right? Your research is different, and then you contribute in that way to find something new. So it's always like, if you think about research as like the surface of a ball, you're adding a little bump on that ball.
There's always more to add on.
It's an add-on, but then it might be a small little bump in a very big ball. So that's how I see it. But I always find like conferences to be helpful. Not only because you get to really talk to people who have come up with the best ideas, or the coolest ideas, but it also gives you a human element to research. It's like, let's say someone ran an experiment and they reported some great data, right? But what they don't say in the paper is what kind of techniques they might be using to get to that kind of results, right? Maybe it's like 10 out of like 1,000 out of 1,000 sets that really worked, and to talk to people who have done the work, you get a sense of what really goes on, like in the labs, in the offices, and then it might inspire you, it might discourage you, right? But there's a take-home message there. It's like try this or don't try this, and you incorporate those feedback. I'm a theorist. A lot. I've started from, so my degrees are in physics, but the work I do has progressively moved more into engineering, like electric engineering and computer science. Mostly because of the applications of quantum computing. So to understand how to do computing with quantum mechanics, you need to understand quantum mechanics and computing. So quantum mechanics is a foundation class you take in physics degrees, like as part of the requirement for graduating in physics. But computing isn't. So I think a challenge that I face a lot nowadays is that to think as a computer scientist takes a lot too, because you need that you have people working in classical computing that have like decades and decades of experience, and they have this build-up of knowledge. And how can you and then to marry quantum mechanics and computing, you have to understand computing as well, right? Otherwise you're just not talking to the people who have been working in computing, and have contributed to today's computers, right? Really, that's a big challenge. I think that's independent of gender. That's the challenge that we face. And there's also other problems, side problems associated with that. One criticism that have come up of this is that if you would like to be a professor, usually the traditional route is to have a very in-depth knowledge of your area, and you have like created a lot of like theorems or papers specifically in that one specialization, and then the university would say, oh, we want this guy because he's the only one who can do this thing, right? But with something as multidisciplinary as quantum computing, first of all, it's a very young area. It's also interdisciplinary area, so you end up having a lot of knowledge about many things, but you might not have like, that cutting that one little thing that you did that only you know how to do it. Yeah. So I think that that sometimes have I've heard criticisms that well, you do so much, but you're not focusing on one thing.
Yeah.
But I think if you want to be relevant for quantum computing, you have to know both sides of the story.
Everything, yeah.
Yeah, you have to know at least these two things. Yeah, no. Well, growing up, when I was a kid, I thought I wanted to be an actress at some point, but I was like flitting between like different things.
Yeah.
Then at some point, I think as a competition with my brother, he was being pushed towards the science part, and I realized this by my relatives, and then I said, well, hey, if he can do it, I can do it too. It's more like a challenge to myself.
Yeah.
So I was like, why not just take his book in science and read it, right? And like do it better than he can. Okay, so what started out as a little silly little thing, it sort of, I said, hey, this is actually cool. And then I when I was in secondary school, I was like 15, I became interested in astronomy, partly because of that reading side interest in science that I started because of competition with my brother. It's a very long sentence thing, but one thing led to the next. I went to astronomy camp, and then I was like, oh, this is really cool. And to understand astronomy, you need to understand physics. So that led me on a little rabbit hole chase. When I went to junior college, then I realized, okay, then I started, I was in Raffles Junior College, and I had recognized that I liked science, and I joined some science clubs, and I realized that actually, on hindsight, I think the boys had more people who were interested in science, maybe more, or maybe they had more support, I'm not sure. But there seemed to be more of them.
Yeah, of course.
So at that stage, then I was one of few among the clubs I was in, science clubs, like physics clubs, chemistry club, things like that. And I think at that stage it started to become clear to me that, okay, this is quite uncommon for girls to like. But it never occurred to me that I couldn't do it before.
That's good.
So that was, not inhibiting. And then that kind of ratio you see, and it gets lower and lower and lower and lower and lower as you go up the academic ladder. So I think it's I wish there were more women. Like I like having more women around me, because I think that's more normal, more reflective of society, right? Like, and that's definitely missing for me. I mean, women in STEM is a subject close to my heart, right?
Yeah.
I've been through it. Maybe I got out okay. I had a lot of help when I was doing my PhD and when I was doing my undergrad, and there were some problems that were specifically for women in STEM, but not all. Okay, like there's some problems that affect everybody. But I think because I had help from groups like this, all right, that I might be afraid to ask in a group of guys. Maybe they would be okay helping me with it, like the guys. But I think because I had help, I really wanted to do the same for people who are a bit younger. Yeah. And I think that even if I can't help them personally, at least I could push them to somebody who can. Level. I think this comes back to what I said. I like to see more of like women in science, in STEM, because I miss that. I miss the normal interactions with a normal balanced group of normal balanced gendered group of people.
Yeah.
Right. Because it changes the dynamics if you have more guys and girls. It does.
Yeah.
It does. And I miss that in talking to people just in STEM. And if there were a lot of guys and not many girls, I feel intimidated. if you're interested,
Anything.
know that's hard. It can be
Yeah.
hard, but don't let anyone tell you you cannot do it. Right? But there are practical things you have to consider, and you have to evaluate whether or not you like it enough to go on